Good afternoon, everyone, and welcome to ISPE's quarterly webinar program. Today's presentation is Smoke Detection and Notification Appliance Circuit Application and Code Updates presented by James Martzall. My name is Emily Widener, ISPE's Education Specialist. I will be your moderator for today. I'd like to go over a few things before we begin. All attendees have been muted to avoid audio feedback issues. All questions will be held until the end of the presentation. To ask a question, please type it into the questions box throughout the program, and I will read them aloud at the end of the presentation as time permits. The slides for this presentation can be found in the handout section of the toolbar. You are eligible to earn PDHs by logging into this webinar for its duration, and you'll be receiving an email later today with your certificate. With that, I will go ahead and hand it over to James.
Thank you, Emily. If anybody needs my contact information, my email is right here, and then Emily can also get that to you as well. So just to kind of review today's agenda, once this slide advances, give me a second here. We're going to talk about the smoke detection. We're going to review the NFPA 72-2016 requirements, as well as new mandatory UL changes, and we will do the same for notification appliances, and then a quick introduction to EST4, and some local resources and some spec updates and engineering support and local resources. So just a quick little bit about me. I've been with Edwards now for 4 years. Prior to that, I sold Hyperspike speakers for 7 years, designing indoor and outdoor mass notification systems. So if you have any questions with Giant Audio or anything else like that, I've been in there. Also, I have a growl license for the bidirectional amplifiers for the firefighter radio systems. I live in Southwest Michigan. You can trust me because I do proclaim that I'm actually a Detroit Lions fan, and no one would publicly address that. For local resources, Edwards actually goes through local distributors around the country. We have 350 Edwards distributors throughout the U.S. Local distributors for the state of Indiana are New Era, ATN, and CSC. They are truly local resources where you can lean on them and ask them for local code questions, or if there's a special runoff question I usually bring them in. As a reminder, today does count for 1 hour of PE credit. So just a quick overview, I do represent both the Edwards and the Kidde fire detection product lines. I manage both. And we're actually this year celebrating our 150th year of being in business for fire detection. Mr. Robert Edwards actually made the first pennant electric bell. I am technically a carrier employee, so it's just my quick PSA. Please don't call me about HVAC questions, only detection questions. So again, if you ever see me ask about the Kidde product line or the Edwards product line, I manage both. There's a lot of similarities between them. So jumping into the NFPA 2072-2016 for smoke detection and visual signaling. Yes, I know Indiana's based on 2010 code, but in the future, when they actually do adopt some codes, you'll be prepared. And there's really not too many changes out there. Usually code just adds more sections, gives more clarification language. They typically never really delete anything away from the code. So kind of question time here, and you can kind of write your answers down here, but I always like to start at the basic. I've been working with a lot of younger engineers. The NFPA 72, the code establishes the blank required levels of performance, extent, redundancy, and quality of installation. Your options are maximum, minimum, necessary, or crucial. And what I like to say is that code is the minimum. So remember, when you're reading NFPA 72, that is the minimum code that you have to do for a facility. Also, two key important words that you have to see when you are reading the code. Shall indicates a blank requirement, and your options are mandatory or recommended. And the answer is mandatory. Shall indicates a recommendation, but is not required. So when you're reading through the code book, you see shall, you see should. Those are very, very, very important words to read, and you'll actually see this throughout the presentation. So when I say the word shall, I hope your ears are perking up. So jumping into some detection and design notes. There are places where smoke detectors can and cannot go. So detectors, they cannot go in below temperatures below 32 degrees Fahrenheit or above 100 degrees Fahrenheit. We live in the Midwest. I think we can see that all within 1 week. We also have to worry about relative humidity and air velocity greater than 200 feet per minute. That's usually if you're in a data center or a hospital where they want a lot of air exchanges to clean the air to make sure it's healthy. especially with the COVID taking off. That's been kind of more of a hot button topic out there. So when you're looking at your facility and you're getting ready to see what kind of smoke detection you need or what type of facility, that you really want to be aware of what type of building is this. Did I accidentally just put a smoke detector in a refrigerator or a freezer room? Is it a conditioned space? Will it have HVAC? Is this a warehouse with some equipment we need to protect and the doors are going to be opening and shutting constantly? Some things we have to consider, and we have to watch these temperatures, or else we're going to have a trouble on our panel. We're going to cause false alarms, and our customer's not going to be very happy with us. So when we actually look also too, that beam detectors, if we had those wide open areas, give us a little bit better temperature rating. So if you do have that wide open environment that's going to be a little bit more fluctuation, beam detectors might be an option. But we also have to look at that the color of smoke. What is actually going to produce the smoke in that facility? We know what type of building this is, but what are the potential smokes that could come out of that building? Are those going to be either hazardous or are they going to cause issues with their fire alarm system? So when we look at the color of smoke, we read more about in code, says the location of smoke detector shall be based on evaluation of potential ambient sources of smoke, moisture, dust, and fumes. And it kind of calls out in the design notes a little bit more back in the annex of NFPA 72. I mean, even engine exhaust, diesel trucks, locomotives, engines, those can produce a lot of nuisance alarms. So a great case in point is I was working with the Indianapolis International Airport. They were building a new building that was going to warehouse all their snowplow trucks. So what they were worried about was that they wanted that building to be protected by the fire alarm. But now we had an issue of really big doors opening and closing, so we were going to be outside of our temperature range. And we had diesel trucks that were going to idle in there and warm up. They weren't sure how the exhaust system really was going to be with that. So what we did is we talked with the engineer, talked with the local AHJ, worked with our dealer on a path forward, and we realized we're going to use weatherproof rated heat detectors. That way they could survive the environmental conditions and we weren't going to get nuisance alarms and they were going to be protected. So what I always say is a 2-minute phone call can save you 2 hours worth of work. So when we actually look at placement for smoke detectors or where spot type smoke detectors can be located, they can be located on the ceiling, or if on the sidewall between the ceiling and 12 inches down from the ceiling to the top of the detector. So our detector can go all the way up in the corner and all the way down within 12 inches from the top of the detector. The reason why I point this out is because smoke detectors and heat detectors have to be treated separately. So a smoke detector can go in the corner. A heat detector cannot come into the top 4 inches within that building. So within that corner of that wall. So be wary of that. Heat detectors, smoke detectors look the same, sound the same, feel the same, but they have to be treated differently based on the criteria. So we look at smoke detection spacing. On smooth ceiling spacings for spot type smoke detectors shall be in accordance with these parameters below. This is a very, very dense amount of information below, but don't worry, I have some examples that I'll show here in a second. So the distance between smoke detectors shall not exceed a nominal spacing of 30 feet. No ifs, ands, or buts. From detector to detector, you're not going past 30 feet. There is an exception. We will talk about that. And that there shall be detectors within a distance of 1/2 the nominal spacing measured from the right angle of the wall partitions. So what that's saying is our first detector from the top of the wall to the left, from the top of the wall to the left of the wall, we have to be 15 feet off. That's where our 30-foot spacing comes from. So we're going to go 15 feet out in one direction, 15 feet out in the other direction. So if I have 2 detectors, 15 plus 15 is going to be 30. We also have to worry about how high our walls are going to come up. If it's going to come into that top 15% of that pocket, we have an issue. Also, we're never going to have a perfect square for a building, so that's why they have this, what they call the 0.7 rule. That all points of the ceiling shall have a detector within equal distance to or less than 0.7 times the 30-foot spacing. So let's jump into some examples of that. So we first said, well, hey, I need to have a detector 15 feet away from the wall and 15 feet away from the wall. Well, we're smart engineers. A squared plus B squared equals C squared. Well, that would give us 21 feet. So based on our 0.7 rule, I said 30 times 0.7, that's 21 feet. That's where that 0.7 rule comes from. So that's when we look at it that way. We also said that detectors can't go past 30 feet from detector to detector. Well, we've all been in a hotel and they have really, really narrow corridors. Code actually calls that out. So if we had 10-foot wide corridors, I can actually extend that spacing up to 41 feet. 11 feet doesn't seem like a lot, but if we were looking at a high-rise application or a really big apartment style complex with corridor smokes, now remember the end user is paying for test and inspect and service on their system. So if we can eliminate 15, 16, 17, 30 devices, that's going to be more cost effective for our customer, and their ongoing test and inspect is going to be a lot lower. So just keep that in mind. So when we look at smoke detectors, this is a quick little quiz. How do we actually know we need for a room? What's the math behind it? You'll be surprised. It's a little bit trickier than you think. So a detector is 30 by 30 coverage. That's 900 square foot. So a detector is going to cover 30 by 30, 900 square feet. But how many detectors do I need for a 40 by 40 room? I'm going to pause here for a second, take a sip of water, let you think about it. So if you answered, a lot of people will answer 2. That's not the right answer. So if you did guess 2, then you were wrong. If we did 1, we're going to be 10 feet short to this side of the wall, and we're going to be 29 feet. We went past that 21-foot rule. If we did 2, we're 10 feet short. The answer is 4. So a lot of people think, well, hey, 30 times 30, 900 square foot, 40 by 40, 1,600 square foot, divide about 1.7, that should be 2. That's not the math. The math is actually a length times width calculation. 40 feet divided by 30 is 1.3. And then the width, 40 divided by 30 is 1.3. We have to round those to 2. 2 times 2 equals 4. This is the real math. Your square footage math will work out sometimes, but this is to ensure that you get the right answer every time. So as we talked about earlier, no building is ever going to be a perfect square. We could have a dome, we could have like a little jot out from a building, but as long as my smoke detector is within 21 feet of that head, we're good to go. Next example is we have an office environment, ceiling height of 8 feet, cubicle height of 6 feet. Do I have to treat each cubicle as a separate room? And the answer is no. But if I did have cubicle heights of 7 feet, we would, because we'd be coming in that top 15%. Right now, we're only with 25%. We're 25% away from the ceiling, not 15% away from the ceiling. The reason why is we have to allow that smoke to come up and to be able to travel and hit the detectors, and that's what they're worried about is if you have high cubicles or other sites out there that are going to high rack storage or anything else like that. So a big growing concern out there is that the high rack storages with these distribution centers. So when we actually look, what are they actually classified as? They're actually classified as a storage group S occupancy, storage group S for storage. So you're like, that's great. I'm going to look up the building code. That's going to tell me what I need for a fire alarm system and how to do it. That's going to save me. What does it show? Well, when you look at International Building Code or Indiana Building Code, that if you look at 907, which is a section for fire alarms, Group S will not show up. Is fire detection desired by the AHJ? That's a question you have to ask. So there's actually a second party out there that has controlling interest. That is the insurance providers. So the new Walmart distribution center on the east, not the west side, the east side of Indianapolis, FM Global mandated that they had smoke detection throughout their whole facility. That's where we use the air sampling system. That's another hour-long presentation. If you're interested in that, let me know. And that's what we had to put throughout the whole facility because there was an insurance requirement. They mandated, the insurance provider wanted to make sure that they were covered. So that's another question when you're working with your clients, you should be asking, are there any parameters your insurance provider might put on this project? So another question, I like asking questions through my presentation that makes sure that you're paying attention. Does the date May 2020 mean anything to anyone? And yes, I know this date's in the past. My wedding anniversary is that month. I should start planning something for my wedding anniversary. We all can agree that's usually when the snow will stop in the Midwest. Or that's when the UL 268 7th edition for smoke detectors should have taken effect. So I really hope you got this right. The correct answer is D. There is actually a 10-minute video on Good Morning America that actually talks about these new mandatory changes. This is the biggest change to happen to smoke detectors in decades. This is a huge mandatory change that is taking place for every single manufacturer. The date was 2019. It was pushed to 2023. I just got word because we're in the middle of June. It got pushed out another year to 2024. Just found that about a day ago. That is now 2024. So be aware of that. So James, what is this change? What are they doing? Well, UL does really fun things where they just like to burn stuff. They like to go through and burn stuff. So they did new to polyurethane foam buyers. They like to make sure that whatever's going in these buildings, that the new detectors will detect, or the old style detectors will detect newer materials to make sure that a fire can be detected. That was it. The biggest thing was the new cooking nuisance alarm test. If there's anything you take away from today, please write this down. If a detector detects burning food, it shall not go into alarm. If a smoke detector detects burning food, it shall not go into alarm. The reason why is that they call it the burning hamburger test. It's a nuisance alarm test. And this is mandated for every single manufacturer for smoke detectors. So Simplex, Notifier, Edwards, Siemens, Silent Night, Firelight, you name them, have to meet this new UL 268 7th edition, has to have this label, shall have this label certified. And it used to say manufacturers had to comply by next year. Again, this moved to 2024 just recently. And so manufacturers can produce 1 billion of them and sell 1 billion of them, but they can't manufacture anymore. Now, another question I get a lot is, well, how do I know if I'm going to get this standard in that room? So UL just made it really, really simple. This is the only type of detector you can buy and install. So it doesn't matter if it's going in a cooking area or a non-cooking area or an apartment complex. This is the only one you can do. Also, for the residential smokes, so for your 120 smokes for apartment complexes or residential use, that's UL 217 8th edition, and those are just now rolling out. I don't handle the residential 120 smokes. That's another one that handle that. If you need his info, please let me know. So there's a lot of incline concerns that do existing platforms support the new UL change. So are you doing specifications out there or working with people that they're going to have a big upgrade to their system? There are manufacturers out there that have to add in a whole new data loop on that. Are they getting the latest and greatest technology? And is it a complex or simple migration path? So if you're working with a customer, you might want to have this discussion with them to make sure, or a vendor to make sure that it's going to be a simple migration path. So the new thing is listed for multi-criteria. It's cooking, steam, and aerosol resistant. So steam is great. I actually have a video here I could show later if needed, but it actually is steam resistant because that'll help for like hotels. Like I once hurt my back, took a really hot shower, opened up the shower door, boom, tripped my sounder base. I was running out of my room with the towel on. It was just my room because I had a false alarm. And we do have a smoke only. That is key because a lot of people are having to add in a secondary sensor to their devices in order to meet that standard. So if I had to have a smoke and CO combo in order to do the analytics to meet that, well, CO detectors have to replace every 10 years. So you just gave that customer a big old upgrade. So, and is everything backwards compatible? That's another question that should be asked. I kind of point this out here. Here's DePaul University. I got this report back in 2019 when people were still in the dorms. As you can see here, cooking. You can see how many false alarms that they've had. And the fire department's got to show up to every single one of these. So when I was working with Notre Dame for mass notification system, their biggest fear is that every time the trucks roll, their fear is that they might hurt a student or hit a student because you have hundreds of kids standing outside of the dorm. So this is really, really going to help this type of environment. So we actually have a case study and white paper on a college campus out on the East Coast where they had the old style detectors and used the new style, and their false alarms went to almost zero. They only had one incident, and that was because the smoke left and went to an area where they hadn't had a chance to upgrade the units at. I have a dealer right now working with a very major Midwest university located in Michigan. maybe on the southeast side, located near Detroit, maybe in Ann Arbor is where that university is located at. And they have upgraded, I would say, I think they're about 3,000 to 4,000 detectors out there. So just very, very helpful in those type of environments. So people always ask, well, how's it doing the analytics and what is it doing? Is what they did is kind of took a three-dimensional report. Instead of just looking at obscuration, they added in extra LEDs to look at it multi-wave, multi-length, to measure the particle size better to determine, is this actual burning substance or burning food? So one thing I like to note just on the Edwards, we talked about backwards compatibility, that our detectors are compatible with our panels that are 25 plus years old. So you can have all the different units out there. So with our old panel that is probably older than me, it's 25 plus years old, or quick start, you can have our Gen 1, 2, 3, and 4 all in the same data loop, no problem. And then I can upgrade you panels all the way to our latest and greatest EST4 with no issue. So watch out for misleading marketing language. I've seen out there that doesn't clearly state that it's listed or certified to the new UL 268 7th edition. Has to stay listed or certified. Those are the key words. Because data sheets could say designed to meet, designed to comply with, complies with. Has to say certified or listed to that. Those are the key words from UL. So really great places for installations are, higher education, teacher break rooms. They usually have a dishwasher that's there, and you open up the dishwasher, the steam comes out. Hotels and apartment complexes. So those are really, really the key locations that are there. So if there are any questions, I encourage you to type those in the chat feature here now while I take another sip of water. And now we're going to move into notification appliances. All right. So jumping in here, notification appliances. So when I would design audio systems out there, my last job, my first question is is this a public mode application or a private mode application? Well, that's pretty key, because public mode, where it's going to go to a central monitoring station, versus private mode, where you're going to have somebody there 24/7 man station that can then call the fire department. Public mode has to be 15 dB above ambient, or 5 dB above maximum sound pressure level. Private mode is only 10 dB. Now, if you remember from engineering school, every 3 dB I increase is a 100% increase in power. So it's almost a 200% power increase from private mode to public mode. That's key when designing a system, because that'll drastically change the amount of amplifiers and wiring and everything else you would need. And another key point that everyone has forgot, that the peak maximum dB level has to be duration of 60 seconds or longer, whichever is greater. So that's very important, because I get these designs for warehouses to be like, oh, it's 90 decibels in there. Like, well, are they wearing hearing protection? Oh, no, it's a warehouse. Well, what happened was the forklift went by, honked its horn, and they thought that had to be considered. Now, you could have like stamping plant or production plant where they have a constant bang, but there's pauses and it's not a constant 60 seconds. You kind of want to take some, common sense approach to that. So when we look at the dB levels and make sure they're accurate measurements, usually when you're in an office environment, school environment, those are pretty copy and paste. But when we look at large factories out there, this is a GM plant. It was 1 million square foot. It has about 90 decibels. The ambient was 75. They wanted to be 15 dB above, so 90 decibels, 87 speakers it took at 2,000 watts. They really liked this approach. They loved the hyperspike speakers, or else it was going to take about 2,000 of the little old bullhorns that you see out there in the field. So the engineer came to me. They like to be safe. They said, what about going to 95 decibels? Well, let's guess how many speakers. 87 at 90, and then jumped it up to 167 speakers and doubled the power requirements. Huge cost implications, So again, when we're looking at these facilities, it's good to take the extra time to get accurate dB levels. Also, too, some code. The average sound, if the average ambient sound level is greater than 105 decibels, shall require the use of visual notification appliances. Well, duh, it makes sense. If it's really, really loud, let's put some blinky things in there to let people know in case they can't hear. Also, too, it says the total sound pressure level shall not exceed 110 decibels at the minimum hearing height. It's typically 5 feet is what they call the minimum hearing height. Well, I get this asked a lot because if it's really, really loud and we got to make it really, really loud in that manufacturing site, how do we get around this code requirement? Well, what do you think everybody is typically wearing when they're in those type of environments? You guessed it, hearing protection. But what does code say about that? Do they actually account for that? The answer is yes. Hearing protection can attenuate both ambient noise levels and audible signals. In spaces where hearing protection is worn due to ambient noise conditions, visual signal appliances should be considered. Well, it makes sense. If it's really, really loud, OSHA is going to make us wear hearing protection. It says, in addition, where hearing protection is worn due to high ambient noise conditions, the audible signals and ambient noise measurements can be analyzed, and the audible signals can be adjusted to account for attenuation caused by hearing protection. Code allows you to take hearing protection into consideration. Exceptions. So in elevator cars or bathrooms, they allow you to go off private mode where you don't need to be 15 dB above ambient, but that requires HJ approval. Now, typically in an elevator car or a bathroom, they're small, they're hard surfaces everywhere. Those are really easy to hit the needed sound pressure levels in those rooms. Now, when we look at mounting height, we have to look at, we have a visual mounting height and an audio visual mounting height and an audio mounting height. So just for audio, notification appliances mounting height is not less than 90 inches. But if I have a combination of audio and visual, you shall go off the visual mounting height. So again, audio only, a horn only, a speaker only can't be less than 90 inches. Audio visual is not less than 80 inches, but not greater than 96 inches, because we have to worry about the candela rating for the strobe part of that. So what I like to say is usually just pick the happy medium, go off 92 inches, and there you go. If you have a mixture, you're fine on that part. So, and also it does call out if you do have low ceiling heights, they want you to be 6 inches below that.
We have a performance-based design criteria that you can use because what we found out with our 115 candela strobe can actually produce 227 candela. So what that allows us to do is we can actually now mount our devices even higher and still meet the minimum lumens per square foot requirement out there. So that's a huge cost savings because if that installer has to then run a man lift, run the conduit, run the junction boxes, that's a lot of money per device for these warehouses. So there's actually 3 safety factors built in. Based on our calculation, we use the hypotenuse angle versus the right side of the wall because we know our longest angle on a triangle is a hypotenuse. So there's one safety factor. Also, the calculation that NFPA references, the UL 1971, actually has a built-in safety factor as well. And our dealers also put in a 10% safety factor. So when they scale the drawings to get those measurements, they come back to make sure they're within or below the 227 candela to ensure that that's there. So you have 3 safety factors built in to give a really cost-effective solution to your customers. So future code changes. We talked about sound over ambient. Code now is looking at light over ambient, believe it or not. So they're actually looking at this. So when we have all these energy efficient buildings for natural light, and then when you look at hospitals or schools with a lot of natural light that are bright, they want to make sure that people can actually see the strobes when they go off. So this is just kind of a fun example. I was at Facebook's corporate headquarters right here. Just for scaling purposes, the top of this building 70 foot. So these windows were just massive. So what happened is they were doing some testing there. All this natural light was coming in, and then boom, you could barely see the strobes going off because of all the natural light. You're looking over the San Francisco Bay. It was sunny. It was nice. So that's the reason why code is looking at those changes to kind of account for that. So just kind of a quick fun story. When you look at the top, this is actually the top of Facebook's roof. Had all these nice trees. And they had this Fox safety sign, and I thought it was a joke. But actually, no, it actually have foxes that actually live on the roof. So we actually did just come out with our new compact wall LED notification appliances. And the reason why I want to point this out is because we had a really reduced current draw, but we only have one tap setting for all the candela ratings. So what that does is that 15 candela and 110 candela pull in the same current draw. So again, backwards compatible with our system, that if these light over ambient conditions take place, we then can use everything to be able to help account for that. That way they don't get having to spend a lot of money to redo their system, add wiring, add extra booster power supplies. So why is this important? It's going to future-proof your customers, no additional equipment costs, simple retrofit, and simple upgrades. So I'd just like to point out that the new panel we have now is the EST4, that this can actually be used as also your mass notification system out there. So if you have school projects, there's a lot of way to interface this with paging solution systems out there to be able to help. And just note, if you do want to look at using the fire system and the paging solution, we do have a specification we can have you look at. So jumping into that, I did show that the system had integrated firewall and cybersecurity, that in NFPA 2022, that they are actually adding language around cybersecurity. They are realizing out there that these fire alarm systems are getting very complicated and everything. So they wanted to address this issue, and this is the whole chapter of NFPA 2022 for cybersecurity. It's saying cybersecurity shall be provided for equipment, software, firmware, tools for installation of methods. They just want to make sure that the system is going to be safe and it will work. So kind of jumping in here to my kind of last question. I'm going to take a sip of water here. If anybody can find what's wrong with this picture. And hopefully you said that smoke detector is way too close to that air handler. Well, that's technically right. I mean, elevator recall for smoke detector is a very, very critical item for a building. But then my question to you is going to be, is that a shall or is that a should? If we look at code, detectors should not be located in a direct airflow closer than 36 inches. So it is not a shall, it's a should. Now, you might have a local AHJ is going to look at that and say, nope, not happening, you need to move that, or that needs to be moved, which is pretty typical. The reason why I call this out is because everything I went over with you guys on, that is with the NICET training. That's a certification for fire alarm systems that you can get out there. And we have a relationship with National Training Center. So if you wanted to go through, get NICET certified so you understand the codes, know how to go through the codes better, how to look this stuff up, great prep class, very, very great credentials you can add to your CV. I went through level 1 and level 2 and passed first try. And kind of lastly, when we come for specification information, I just ask to make sure that you have Edwards listed on your master specification, because a lot of times I see really, really old specs or we're not written in the specs. I'm just asking that way we can come there. Also, if anybody would like some design notes, I did make a educational design note document for K through 12 schools. It's more centered towards Michigan, because in Michigan, any K through 12 school that has greater than 100 students shall be audio. I also made an elevator design note, so I got a lot of questions on elevators, smoke detection, relays, what's required when it's sprinkled or not sprinkled. I have that as well. It's a good little cheat sheet. So let me know if you ever have any questions. Also, too, me personally, will be starting a Society of Fire Protection Engineers networking chapter. I'm going through the approval process right now to get that. So if you see that, want to join about it, it's a really, really great organization. I'm very active in the Michigan chapter. This would be a great one to have in the state of Indiana. So be on the lookout for it. If you want to participate, you want to be in the group, definitely looking for volunteers, and let me know. So other than that, I am completed with my part of the presentation. Used to having a little bit more interaction than questions at the end, so I think now's a good time if anybody wants to ask their questions.
Like I said at the beginning, if you have any questions for James, please place it in the question box for him. James, is there anything you want to add while we wait on that?
Yeah, the one thing I also like to add and talk to engineers about is when you look at your specification, that make sure that your drawings and your spec are matching up if it is a horn strobe system or an audio system. Just because an audio system is about a 30 to 50% higher price than a horn strobe system. And the reason why is, well, I got to run an extra pair of wires for the speaker circuit and the strobe circuit. I then have amplifiers. I then only have a limited amount of space in my panel where I might have to add a second panel. So that's one of the biggest things I see out there that's often missed with engineers. Also, too, some really helpful links that I've told people is upcodes.com and or International Fire Commission codes. That's the International Fire Codes. They're all free online where you can look up the latest codes. They have prior year's codes and new year's codes. And the great thing I like about that is they color code it to show you what's been changed, added, or deleted. So if you ever have questions on stuff, one thing I always kind of recommend for people is to look at future versions of the code because sometimes it gives more clarification language. In case in point, if you're looking at like a use group B for occupancy, current code doesn't really clearly state that it needs audio visuals throughout. And then when you look at 2022 code, it clearly states that. So if you have any questions, it's really helpful to look at future versions of the code because it will help with clarification out there.
Okay, it looks like we did have a question come in. It says, how do we comply with the temperature limitations for smoke detectors in rooftop air handling units?
Yeah, those are going to be listed for the rooftop air handling units. Typically of how there's going to be. Some rooftop air handling units have one built in already, or they have to caulk it and make sure that it's there. But as long as they're specified in there, the installer or the fire protection company that's going to do the work or bid the work is going to know how to account for
that. Okay, it doesn't look like we have any other questions. If you have anything that you want to ask James, his email is on the screen, or you can reach out to me and I can direct any questions to him. But I guess that's all we have for today.
All right, thank you very much.
Yep, thank you. Thanks, everyone.